So now we move on to the second exercise, that is exercise 1.2, and this exercise is all about 1, and onto function. So first of all, we need to have a clear idea what is 1 function. So 1 function is basically, it's a function in which every element in A must have a distinct image in B. So what do you mean by that? So when I'm going to write a function, so here we have a set A and here we have another set B. So if I have some elements in A, suppose I'm writing 1, 2, 3, and if I have some elements in B, that is 4, 5, 6 and 7, if I write like that. Now if I say that 1 is related with 4, so I will give it an arrow mark, 2 is related with 5, then 3 is related with 6. So you see every element in A has a distinct image. Distinct image means they have different images. So, and here you write F because it's a function. So you can say this function to be 1 function. Now it doesn't matter what is in B. If there is an element in B which is not related with any element in A, I don't care. It's all about that every element in A must have a distinct image. That condition has to be satisfied for 1 function. Now you might be asking, suppose I have a function like this. Suppose I have a function like this. Now this one is still a function, but it is no more a 1 function. This one will be many to one function. Why? Because the image 5 is common to both 2 and 3. So this is not a 1 function. So we have understood the idea of 1 function, right? So basically, in order to prove a function to be 1, all we have to do is we have to start with fx1. We have to assume that fx1 is equal to fx2. Then at the end, we have to check that this fx1 is equal to fx2 must implies that x1 is equal to x2. So this is how we should proceed for 1 function. So we will assume, so let fx1 is equal to fx2. Then from the step, we'll go to the last assumption, last inference, that x1 must be equal to x2 to show that the function to be 1 function. Now the last one, that is onto function. So what is onto function? So onto function is basically, it says that every element in B must be related with every element in A. So in the previous thing, we saw that in the previous where we have done the markings in here, the mappings, 1 with 4, then 2 with 5, then 3 with 6. Once we did this one was 1 function, but this one was not onto function. Why? Because here in the element 7 is not related with any element in A. So we can say that this one was not onto function. So which one is an onto function? So all you have to do is put an element in here, 4, and give it a relation like this. So now you see this one is an onto function. Okay, so let's start with it. Now how to do onto function? Now for onto function, suppose if you have a relation like this, fx is equal to 2x plus 3. Suppose you have a problem like this and you have to prove that this function is onto or not. So what you will do is, for this problem you will write let y is equal to fx. You start with this assumption, y is equal to fx, then y is equal to 2x plus 3. Then you have to express this expression in terms of y. So you have to express x in terms of y. So what we are going to do is, so I will take y minus 3 is equal to 2x. Then therefore x is equal to y minus 3 by 2. So now if you look at y minus 3 by 2, it will never be undefined. Why it will never be undefined? Because we know in class 11, while we are finding domain and range, we used to see that square root of a negative number, it becomes undefined, or anything divided by 0 becomes undefined. So these are the two conditions where the function becomes undefined. So I don't see y minus 3 by 2 will ever be undefined because there is no square root, and the denominator will never be 0 because it's 2. So this will always be defined. So you can see that, so x value can be y minus 3 by 2. It is possible. So what I am going to do is, in place of x, fx, in place of x, I will put y minus 3 by 2. So I will put here y minus 3 by 2. So if I put, and if I get the answer as y, then we can say that the function is onto. So in place of x, I'm putting y minus 3 by 2. So I get 2 into y minus 3 by 2 plus 3. So 2 gets cancelled. So here we are getting y minus 3 plus 3, that is equal to y. So now you can say that this one is an onto function. So now we have learned that how to prove whether a function is onto or a function is 1, 1. So let's start with one question, that is question number 10, and let's solve this question. So we are doing exercise 1.2, question number 10. So the question says, let A, so they are saying the relation, let A is equal to, first I'm just doing a rough idea of it. So A is equal to, they have given r minus 3, and then B is equal to r minus 1. So they have given these two datas, these two sets A and B, where A is all real numbers minus 3 and B is all real numbers minus 1. Minus 3 means what? The element 3, the number 3 is rejected, the number 1 is rejected from B. And the function is from A to B. The function is from A to B. Basically this means what? It means that this one is A, this one is B. The function is from A to B. So this is where it is going, from A to B. So A represents the x value and this B side represents the y value. Basically it is f of x, right? Clear? So this is what we have in the question. Now the function that is given, now that's the most important thing. The function is x minus 2 divided by x minus 3. So we have to prove that the function is 1, 1 and onto. So how will we start with this question? So for 1, 1, we already know that we have to assume that for x1, x2, fx1 is equal to fx2. So what we are going to write here, let us write for 1, 1. So we are proving for 1, 1. So for 1, 1, what we are going to do is, let there be x1 and x2 and x2 such that fx1 is equal to fx2. So I am assuming two values x1 and x2 such that fx1 is equal to fx2. So now this must imply at the end x1 is equal to x2, then only we can say that the function is 1, 1. So fx1 is equal to what? Fx is this thing. So fx1 will be, in place of x you write x1. So x1 minus 2 divided by x1 minus 3. This is my fx1. And fx2 will be what? x2 minus 2 divided by x2 minus 3. This is my x2. Now we will cross multiply. So we have x1 minus 2 into x2 minus 3 is equal to x2 minus 2 into x1 minus 3. So let's multiply. We have x1 x2, then we have minus 3 x1, we have minus 2 x2, then we have plus 6 is equal to x2 x1, then we have minus 3 x2, then we have minus 2 x1, then you have plus 6. So let's see what are getting cutting. What are getting cut? So 6 gets cut out. This one x2 x1 this one is getting cut. And then let's do one. Let's take all the x1 one side and all the x2 other side. So here we have minus 3 x1. So minus 2 x1, this goes here. So we have minus x1. Minus 3 x2 and minus 2 x2 goes that side, become plus 2 x2. So we have minus x2. Now therefore we can write here, therefore x1 is equal to x2. So once we see this thing, that fx1 is equal to fx2 implies that x1 is equal to x2. So we can write here, hence fx is 1, 1 function. So we can write this thing because we have proved that one. Now we have to prove for onto function. And for onto function, what we are going to do? For onto function, we have to assume a value y. So y is equal to fx. Look at here. We have done here what? Y is equal to fx. So we have to assume a value y. So let us start this question. For onto function, so we are going to do is let there be a value y such that y is equal to fx. So I am assuming one particular value y such that y is equal to fx. So here we are going to write here y is equal to, now what is fx? Fx is x minus 2 divided by x minus 3. Now what was my next step? My next step was to express x in terms of y. So I will just cross multiply and I have x minus 3 into y is equal to x minus 2. So let's multiply. We have xy minus 3y is equal to x minus 2. So let us take all the x terms one side and the rest the other side. So what we have, or xy minus x is equal to 3y minus 2. So if I take x common, or x, y minus 1 is equal to 3y minus 2. So therefore x is equal to 3y minus 2 divided by y minus 1. So we are getting 3y minus 2 divided by y minus 1. Now if you look at this one carefully, if you look at this value carefully, we see that there are two conditions when the function becomes undefined. The first one was square root of a negative number, and the second was anything divided by 0. Anything divided by 0. But if you look at this one carefully, we have what? 3y minus 2 divided by y minus 1. This thing will become undefined when y is equal to 1. Why? Because when y becomes 1, then 1 minus 1 it becomes 0. So basically this becomes what? 3y minus 2 divided by 0. So the entire thing becomes undefined, right? But one thing you see in the question, they have given here. So in my mind, just keep it fixed that when y is equal to 1, the function becomes undefined, right? So now let's move back. What I told you, that this function is from a to b, right? The a values are for x and the b values are for y. B values are for y. What is the b value in here? In the b value section, you see that b is equal to r minus 1. So r minus 1 means what? One value is rejected. So one value is not present in b. If one value is not present in b, so it means what? The y can never be 1. So if y can never be 1, so what we can say? So this function will never be undefined. 3y minus 2 divided by y minus 1 will never be undefined. Why? Because the value of y, it will never be equal to 1. Because it says b is what? R minus of minus 1. So they have rejected 1 from there. Okay. So what we are going to write here? So in place of x, we are going to write 3y minus 2 divided by y minus 1. So f of 3y minus 2 divided by y minus 1 is equal to what we have. So fx, our fx, now look at here, we have to remember this thing. Fx is equal to what? X minus 2 divided by x minus 3, right? So I need to put what? In place of x, I will put 3y minus 2 divided by y minus 1. So we are putting 3y minus 2 divided by y minus 1 minus 2 divided by 3y minus 2 divided by y minus 1 minus 3. So let's see whether we are getting y or not. If we get y, then that's it. The function is onto. So if we do the LCM, we get minus 2y plus 2 divided by y minus 1, then entire divided by 3y minus 2 minus 3y plus 3 divided by y minus 1. So if you look at carefully, this y minus 1 gets cancelled. So in the numerator we have minus 2, this one gets cancelled. So we have y, and minus 3y gets cancelled. So denominator we have 1. So you are getting y. So we can say that for every value of x, that is 3y minus 2 divided by y minus 1, we have a value y. So we will write for every x equal to 3y minus 2 divided by y minus 1, we have a value y. So the function is onto.